Okay, so in the previous video we had a look at how we could summarize the data to produce an estimate for, as it turns out, distance to particular airports, number of flights to those particular airports, and then we looked at the average delay, which then we put a trend line through, and what we observed is the further in terms of distance a particular destination is, we find that for as the distance increases, then the mean delay actually is reduced. And in some respects this is counterintuitive, because you might expect that for longer distances there might be greater delays, but as it turns out, we could intuit perhaps that as the average distance to given airports, destination airports increases, the ability for pilots to make up delays, the scope to make up delays, to compensate for delays by flying faster, is available. And so by flying at higher amount of speed, pilots can then reduce those deficits in flight. Okay, so the way we approached that was a bit complex here, but it's the way suggested in the R for Data Science, just to demonstrate that if we were to estimate the average delay for given locations, we could have used this combination of code. When we graphed here, we used the ggplots, and again, the ggplots is a powerful way of visualizing any set of results that we have. But we do have mean of distance and mean of delay, and we can set this out as on an XY axis in the fashion we've done here. And then we can put a trend line through, and the smoothing, instead of an ab line, we have smooth, and that allows us then to follow a little bit more the contour of the data as opposed to a linear relationship. And then other variables here, the aesthetic we include because it's an ordinal value, in the sense that the number of times a particular flight occurs to a given destination, we did count the number of flights to each destination, and then that registers. So if you have 4,000 flights, it's a bit small. If 8,000 flights, it's bigger. And if 16,000 flights, bigger again. So those destinations with large number of flights, they appear here with the larger dot. Okay, now we can tackle the same problem using a pipe operator, and again this is also a useful way to introduce the pipe operator in dplyr, and we group by, if you like, we can group by the destination. Okay, so again we could have obtained the same results that we obtained here, but we can tackle the same problem by using this type of code. So let's go back into R for Data Science for a moment, R for Data Science, and okay, data transformation, and then we come down to grouped summaries. So we had done it by day. So this is the code that we had implemented. We had generated the graph. It looks like the delays increase with distance up to 750 kilometers, so about here, and then decrease maybe as flights get longer. There's more ability to make up delays in the air. Okay, so that's just an idea, hypothesis perhaps, and this is to visualize. And there are 3 steps to prepare this data: group flights by destination, summarize to compute distance, average delay, and number of flights, filter to remove noisy points. So Honolulu was excluded from our data here. We removed Honolulu, and then which is almost twice as far away as the next closest airport. And then we, because it's just a few, if there was just a few flights to a particular destination, might be so reliable, the mean estimation, so that's why we exclude less than the 20 airports with, or destinations with less than 20 flights. So this code is a little frustrating to write because we have to give each intermediate data frame a name, even though we don't care about it. Naming things is hard, so it slows down our analysis. There's another way to tackle this. The same problem with the pipe operator. So we could have applied a pipe operator and we group by destination. So if you like, we create a variable delays, and it takes the entire data set, and then the pipe operator can be read as and then group by destination. Okay, so we break down our data into the destinations, and then summarize by counting the number of flights to that given destination, the distance, and again we need to take the mean because there's 3 airports in NYC flights 13. In New York there are 3 airports, LaGuardia, JFK in Newark. So we have to take the mean to a particular destination and then the mean delay, and then apply the filter, select out the data that is excluding destinations that had flights less than 20 and excludes Honolulu, right? Again, because these are viewed as being noisy. Okay, so let's run that, go back into RStudio and run this snippet of code. Okay, so we come back here, delay, and we're using the pipe operator, and we run, and then we have again delays. So this time it's delays. So before it was delayed, now we have delays. Okay, so if you look, the time before we delay, this time we have delays, which we can view, and we've reproduced exactly the same subset of data. And again, we can do flights. Again, if we wanted to, we could do ggplot. So I could take this again, copy, and I perhaps will delete this. So paste. And then instead of delay, put in delays, which would mean this data set that we just created. Run, and I'll get rid of this for a moment entirely, and then just run ggplot. The data is delays and the XY axis is as before. Okay, so we can see here it's clear that this delays data is exactly the same as the delay subset we created before. I'll just take that out for the moment. Okay, but this seems to be a more efficient way. And again, if we go back to our R for data science and look at the operator look at the syntax that's been used here from Garrett Groland's YouTube video clip for data manipulation tools, dplyr part 3, we can see group by offers a way of categorizing, putting the data into separating the data into identifiable categories, and then we can group by and then summarize our data in that particular fashion, then take the mean of each of these. Okay, so the group by allows us to define neat categories very efficiently, and that's something here that is presented in the dplyr syntax. Okay, we go back into RStudio for a moment. We can observe how our code is set up. and if you like, perhaps go into the data transformation for a second. So this focuses on the transformation, not what's being transformed, which makes the code easy to read. You can read it as a series of imperatives: group, then summarize, then filter. Okay, so we group, then summarize, and then we excluded values based on some criteria, or included values based on some criteria. As suggested by this reading, a good way to pronounce the pipe here when reading the code is then, or and then. So group by destination, or take the flight data and then group by destination, and then summarize, and then filter based on some kind of criteria. Behind the scenes, X pipe operator Fy turns into Fx comma Y. So in other words, we're defining a function. We'll use piping frequently from now on because it considerably improves readability of code, and we'll come back to it in more detail in pipes. Okay, so this is one of the kind of the strengths here that's being presented, that we have this pipe operator. We didn't, in this instance here, we didn't use it in the ggplots, but here we have used the pipe operator and the group by and summarize, and this is helping to streamline the code and make our syntax efficient and understandable. So one of the strengths of dplyr.